Hi, welcome to SQL lesson 4. We're going to continue to talk about functions in this lesson also, as we did in the previous one. So in the previous lesson we looked at aliases and aggregate functions. Some of them are count, average, these are the aggregate functions that we looked at. And in this lesson we are going to look at group by and having clauses. These are actually an extension of the aggregate functions and they work along with the aggregate functions. Now after that we are going to look at some string functions. The group by clause, let's see what we have here. They are mostly used to group results for one or more columns. Like if you want to select the trip expenditure by, let's say, by sex or by age group, then in that case you would be using a group by clause. So that's pretty much what we are saying here. They are used along with aggregate functions like sum, average, etc. Now if you have any columns in the select statement, they must appear in the group by clause unless those columns have an aggregate function in the select statement. So we'll be taking a look at some examples. This will become more clear to us then. Okay. Let's look at the group by clause syntax. We have the select column name and another column on which the aggregate function is being applied. And then we have the from table name, which we know is a must, and then an optional where statement. And then we have the group by, and this column in the select is pretty much the same one in here. Whatever column on which you apply the aggregate function is generally not included in the group by. It actually doesn't make a whole lot of sense to do that. But when we do the examples, I will point out what will happen if this same function is repeated here. But anyway, one thing to notice, the group by must appear after the from, and if you have a where, after the where statement. The order of these statements is pretty important. Then of course if you want to include an order by, then it's the last statement that will appear in the SQL statement. Okay. Now let's look at the having clause. What does having do? It actually acts like a where clause, but it mostly works with aggregated data. And it filters records and we can use it with aggregate functions. Let's say for example in a where statement, for example, you cannot say where sum of a column is equal to or an average of a column is less than. You cannot use such a filter in the where clause, but you can use the having clause for that purpose actually. So that's the difference between these two. Now if you have columns in the having clause, then they must either be in a group by clause or they must have an aggregate function tied to them. Okay, once again, it's all easy to say, but I think things will become more clear when we actually run some examples. Now let's say you have a where clause, you have a group by, and then you have a having. How are they processed? Whatever filter you have in the where clause, that's always processed first. Then the data are grouped, and finally the having clause filters are applied on that group data. Okay. Now let's look at the syntax for the having clause. So you have a select column name, the aggregate function on another column, from and the where clause, which is optional again, group by, and there we have having after the group by clause, and then you have the aggregate function on a column, operator and value. See, pretty much very similar to the where, which has a column, operator and value. Here additionally you can use an aggregate function on the column, operator and value. Lastly, if you have an order by, you would be including it after the having clause. So this is pretty much the whole syntax for the group by and having. Let's run some queries so things will become more clear to us. So we are in SQL query now. We are using the SQL Server Management Studio. I've included a couple of additional columns like age group and also email actually. In this table main contact, so actually we can do our queries, and it'll help, these two columns will help us understand how the group by having conditions work. Additionally, it will also help us perform the functions, string related functions. Okay, so let's execute this and look at the data. So here you can see the age group. So from 10 to 20 is age group 1, 20 to 30 is age group 2, and so on. So I've just provided some grouping here. Okay, and some email addresses for each of my contacts. Now let's switch to the group by first and see how it works. Here I have a select sum of trip 1 expense from main contact and group by the age column. Let me order by age. So let's execute this query. It's a very simple query where we are grouping by the age to get the trip expense. So we got the expense, the sum of the expenses, but since we didn't include the column age, we don't know what these expenses are related to. So let's go ahead and include that column here. Once you execute, then you realize, oh, for age 13 it's 14,335, for age 24 it's 8,627, and so on. Okay, so including this column of on which you are grouping by is extremely necessary, otherwise the expense won't make sense. So let's go ahead, copy the query. I'm going to add a column called gender. You see, I have added it only to the select statement, I haven't changed anything. Let me run the query and see if it actually works. It says, okay, first of all I didn't include the comma, so let me do that. It says it's invalid because it's not contained in either an aggregate function or a group by clause. So pretty much any column that is not in an aggregate function, like trip 1 expense, you are aggregating it using the sum function. So this column has to exist in the group by, or it must have some kind of count or something going on by gender, otherwise it won't work. So let's go ahead and include gender here and see how it works. Yep, it works now pretty well. So for age 13 female we have 10,335, for age 13 male we have 4,000. Perhaps including a count would also help us understand how many people are part of this grouping. So count of people. Okay, I execute the query and now you see there are 2 females aged 13 whose expense is this much, male 1 13 years old and the expense is 4,000, and so on. So as you keep including the different columns or the aggregate functions, things sort of fall into place and it will help us understand. Now one thing I want to show you is, let's copy this query. If I include the trip 1 expense as part of the group by, what happens? Let's execute this query. If you notice, it's showing 18 rows of data, which is actually the whole number of rows in this table. So nothing has been grouped by. That's mostly because whatever you're summing by, that column is also in your group by clause, so it doesn't make sense really. So if you want to group by something and you use this function against a column, that column must not appear in the group by. Okay, so only then things will work, otherwise you will just see the whole number of rows but it won't do the grouping. Now let's look at including a where clause. Let's include a simple where clause where age is less than or equal to 30. Here we can see everybody whose age is less than or equal to 30 has been included. So the where clause is applied, and then you group by the age and gender, and you are getting the trip expense, summed up trip expense by age and gender. That's what you are getting here, the result set. So depending on what you want to do, you have to include, exclude certain columns and use the appropriate aggregate functions. Okay. So this is one way of using the group by and condition. Let's look at the having clause now. Here I have a simple statement. Select age group. This is not the age column, this is the age group. Sum of the trip expense from, and then you have a group by, having sum of trip expense more than 5,000. So once you group by the age group column, give me the summation, give me the expense where this summed up expense is more than 5,000. That's what I'm asking for. So age group 1 here is 22,112. So this is what we are getting as the result set. Okay. Very simple statements, but as you go you can increase the complexity. Now I can say where age group is greater than 1. So I am excluding those with age group 1. Execute. I could also use where age is less than or equal to 30. See, this column obviously doesn't need to exist in my select statement. But if I want to pull up records only where age is less than or equal to 30 and then perform my select, group by and having clauses, then utilize those, this is what I can do. So age groups 3 and 4 have been eliminated because those do not belong to this age of less than or equal to 30. So those contacts have age more than 30 years. They are more than 30 years old. That's why they haven't been selected. Now let's look at what happens if I remove this sum and just keep this statement. So I have select age group, sum of my trip expense, summation of that from group by, and then I said where my trip expense is more than 5,000. Is that going to work? Let me see. Nah, it doesn't. It says having clause is invalid because it's not contained in either an aggregate function or the group by clause. So basically this has to have the aggregate function. It could also be an average, by the way. You don't have to only sum. You can try an average expense by age group. So now you can see that you have to have this in an aggregate function or this must exist in the group by. They mean the column trip 1 expense must either be part of an aggregate function in the having clause or it must be part of the group by. We'll see shortly what happens if it's part of the group by. Here we have it. So this is the average expense actually. Now let's go back to the other part of the query where, since it complained earlier that trip 1 expense has to have an aggregate function or it must be part of the group by clause. So let's see what happens here. One thing is, we have already seen if we include trip 1 expense in a group by clause and also it has an aggregate function, these two sort of negate each other and we get back all the rows in the data. And then on that, if you are applying having trip expense more than 5,000, what does that mean? It's going to return all the rows where trip expense is more than 5,000. Pretty much very similar to using this select age group trip 1 expense where trip 1 expense is greater than 5,000. So let's put this in another window so we can compare the results and see. I'm going to put it here. Execute. So we're pretty much getting the same result sets. 7345 for age group 1 there are 2 people, 7777. So same results, same number of rows, 11 rows here and 11 rows here. So what is happening here is basically these two are pretty much negating each other. So this one is taking out the summation part completely. So we are getting back all the rows, and this is pretty much, we said, like using a where clause, right? So that's why it's returning the rows where trip expense is more than 5,000. It's similar to using this. So just something to watch out and make sure that we don't include such things, because instead of writing this whole long query, we could just use this short version of it, right? So if you really want to get the benefit out of group by and having, use something like this, where we have aggregate function and in the select as well as the having, and the other column that you are grouping by is in the group by clause. Okay, so then only then it makes sense. Now we are going to look at some functions, string functions basically. Okay, so continuing on, we are going to look at the string functions. These are all some very basic string functions. We're not going to go in depth with, because there are like way too many string functions available out there. I'm just going to deal with some basic stuff that we use in general. Uppercase and lowercase letters, U case or L case in some programs. How to trim them, the trailing and leading blank spaces. Like if you have a email address, you could have some blank spaces all the way towards the right or left. If you want to trim them, these are the functions you'd be using. However, if you have blank spaces in between the letters, then those blank spaces will not be removed. Now we also have the concat function, which we looked at before. Actually, we used the plus sign in SQL Server. These are the choices available for concatenating 2 or more strings. And len gives us the length of the data, which is useful in a lot of cases, and it goes along with the substring in some examples. We could use that as well. And substring is a very important function that I found to be extremely helpful to me in very many cases. When you want to extract a specified portion or a specified number of characters from a string, so in that case we use this substring function. So upper and lower functions, let's look at the syntax. Just select upper column name, and you just include your table name and other where clauses, whatever you would like to. And lower converts the data to the lower case. Obviously upper converts all the characters to uppercase. And since these are string functions, you won't be using them with numeric data. Ltrim and rtrim, let's look at those. Select trim as column alias. If you want to include the column alias, you could do that. If you don't, then the column name will not be specified. This removes the leading and trailing blank spaces. One thing to note is this trim function is actually, it doesn't work in SQL 2008. So we could use a combination of ltrim and rtrim, which I'm going to talk about here. So ltrim, it actually removes the leading blank spaces. That is the blank spaces towards the left side of the column, or the characters actually. Rtrim, it's going to remove the trailing blank spaces, the ones towards the right side, like following your characters, whatever spaces are there, then those are going to be removed. Now the concat function, This is how you would be using it. Select, concat, and you separate out all the strings that you want to concatenate by commas. One thing is this doesn't work with SQL 2012, so I won't be able to show this to you, but it's available if you have SQL Server 2012 or any latest version. Other ways is you could use the plus sign, which is what we already dealt with, but we could look at some examples again. Now these two parallel lines are something that certain systems or programming languages use, but this doesn't work in SQL. So only the plus sign works right now for my case. Now let's look at the len, or the length function. What does it do? It gives us the number of characters in this column basically. So when you say length, it's going to count the number of characters and give you that information. You could also use length fully spelled out. I guess it depends on the system or the tool that you're using where you are running your queries. So check it out, please. Now the substring function, here we are going to say select substring, whatever column name or even expression, in the sense like you could put something in quotes and that becomes a string here, single or double quotes. What is your starting position? Where do you want to start in the string? And how far do you want to go? In the sense, do you want to get to 4 characters, 5 characters? That's the length you want to specify. So this is going to select a portion of the data in a column. In some systems it is substring is fully spelled out, and in some it is just substr. So once again we have the starting position and the length. Okay. So here we are going to look at the main contact table once again to look at the last name, first name and email columns, because most of our string functions will be applied to these. As you can see, the last name is a mixture of upper and lower case, and same goes with the first name. And here we have some email addresses. We'll be looking at the function shortly. Now let's go here. I've already set up the queries. Here is the upper function where we have the last name, and we are using the upper function on the last name to convert all the characters in the last name to uppercase. And then we are doing the same with the first name. Okay, let's execute the query. And as you can see, every single character is in uppercase. Actually, a lot of these are helpful when you write queries and want to compare some names. You want to make sure that in SQL, of course, it's case insensitive. In other words, upper or lower comparisons don't matter, but in some programming languages, the upper and lower cases matter a lot. So when you're doing comparisons, you want to first select either all in upper or all in lower before you compare, and I found them to be useful that way. Now you can apply a where clause as you want to and try out different things. Here is the lower case, the same thing. You are applying the function lower to the last name as well as the first name. So when you execute the query, you can see that all the characters have been converted to lowercase. Okay, so this is how the upper and lower works. Let's look at the trim functions. We have the ltrim, rtrim, where we can't use the trim function per se in SQL, but let's see what we can do about it. First thing is, it's going to trim, the ltrim is going to remove the spaces towards the left side of the email address. Now before we go ahead, let's see, here we have one email address which has some spaces towards the left side. How do we know if it's actually trimming these spaces or not? That's why we are going to use the length function to see the length before and after and compare and see is it doing a good job or not. Execute the query. When you go all the way down, pretty much most of the cases you see the length before and after trim is the same. Whereas in the case of Ram Ghanti, we can see the length before is 24 and after is 21. So that means it has trimmed the spaces, And what I want to mention here is we are checking the length of the trimmed email here. So you can apply more than one function on the same column. So that's one thing we can see here. And the same way we can do with rtrim, which is going to trim the blank spaces if any exist towards the right side. Here it may not be as obvious because it's hard to see the before and after. I mean, if there are any blank spaces, it's not so easy to see them. But I don't have any with blank spaces towards the right side. So pretty much the length is same before and after. Now if I want to apply a trim function, I want ltrim and rtrim together, and that's the way to make it work in SQL right now. Maybe in the future they are going to change things. So let's see what happens if we do ltrim and rtrim on an email. As you can see, all the leading and trailing blank spaces, truly speaking, they'll all be removed. And here you can see 24, and it's 24 before the length of the email, and then it is length is 21 after the ltrim rtrim have been applied. So pretty simple, but a lot of cases again when you are comparing things, blank spaces do make a difference in certain programming languages. So this is one of the reasons why we need to pay attention to it. Now let's see how to combine two columns. We have already seen to concatenate we use the plus sign. Just bringing it up again to refresh our memory. So we use the plus sign to combine two or more columns. So here we are combining the name. In general, most of the time we use last name comma first name. So I'm just throwing it in here. Okay, I misspelled the first name. Good to know that it's still checking. So we have Schroeder William, Chintam Subbu, Rao Priya, so on. So when we want to combine columns, this is how you would do it. Now substring. What is substring going to do? It's going to pull up part of the information from a column. So here we are saying my column is first name, apply the substring function on it, starting from position 1 and go up to 3 characters. So this is the length up to which we want to go, and this is the starting position. So let's try this and see. So here we have first name now trimmed to the first 3 characters only. Okay. Here is another example where we are also picking up the last name starting from position 1. We are going all the way to position 6. And for email, we are starting from position 4 and going up to 5 characters. We pick up 5 characters starting from position 4. In some cases, if the last name, let's say, has only 3 characters, earlier I remember in some systems it used to generate an error, but SQL Server doesn't care, really speaking. See, for example, Joe Banker doesn't have 6 characters. So let's see what it does. It doesn't complain. It just picks up the first 3 characters only, even though this last name is less than 6 characters. Okay. So, and here you can see the email, it picked up the 5 characters starting from position 4. So maybe if we include the email, it's easier to see that. Okay, we go here. So starting from position 4, so we exclude bill 1. So we start, okay, from position 4. So L1, 2, 3 act is what it's selected. So this seems to be working fine. One of the things that I noted is if you want to go all the way until a certain character within a column. Let's say, for example, in our email, I want to go all the way up to the @ sign and pick up everything that's there before or until the @ sign and excluding the @. Okay, because Sometimes we don't know if people are including their, let's say, just their name and gmail@gmail.com, whatever. So then I want to pick up that name and exclude everything else that's in the column. So here I'm going to select the email, and let's look at this substring for a second. I'm applying the substring function on the email. I'm going to start from position 1. I want to go all the way until @ sign, but in each email the @ is at a different position. It's not at the same position for every single row. So for example, bill 123 @ you have 1 2 3 4 5 6 7. The position is 8. For wagnerst@gmail.com it is 1 2 3 4 5 6 7 8. We have at the 9th position. So how do I pick up these characters, different positions where the @ sign appears? So how do I pick up all the characters until that @ sign? For that we are using a car index function which is available in SQL, and it automatically looks at this particular column or cell and it says, hey, your position of @ in this email is at 8 for Schroeder. For Wagner it is at position 9. So that's what this car index is doing. So I'm saying apply the car index function, find me the position of @ in the email address. Okay, but however I don't want to include the @ sign in my result set. So I'm saying go back 1 position. So I go all the way until @ and move back 1 position. So I'm going to say Wagner st at 9 characters and then go back 1 position, which means 8. So starting from 8 1, I'm going to go all the way up till I'm going to pick up the first 8 characters in this case. So let's execute this query and see if it works. So in every case it actually goes all the way until the @ sign. If you can see, Priya Rao 3 at Gmail. So my new column has Priya Rao 3. From @ sign it excludes everything else because I don't need that information. Now you can apply ltrim, rtrim, whatever functions on the same substringed column, and then it will remove the spaces that you have. So this is how the substring function works. Please try out as many examples as you can, because this is one of the most important functions that I have used a whole lot, and it's comes in handy if you know how to do this. So with this we are going to end the lesson, and then we'll meet you with the next lesson pretty soon. Thank you for watching, and goodbye.